All right, numbers 11 through 18. I'm just asking you to find the domain, so just kind of testing to see whether or not you know what the issues could be. When you got a square root, you always have to set the interior greater than or equal to 0. So 5 minus x is greater than or equal to 0. Negative x is greater than or equal to, you're going to subtract the 5, negative 5. When you divide by a negative, it flips. X has got to be less than or equal to positive 5. So my domain would be negative infinity to positive 5. For number 12, this is the rational function, so you have to worry about when the denominator equals 0. So 2x plus, just kidding, 2x plus 5 cannot equal 0, which means x cannot equal negative 5 halves. Okay, so my domain is negative infinity to negative 5 halves, not included. Pick back up at negative 5 halves and go to infinity. And there we go. Number 13 is a polynomial. It's a cubic function, therefore its domain is all real numbers. Number 14 is a logarithm, and as far as logarithms go, I don't know if you guys remember, but an exponential has a horizontal asymptote and does this. It has a horizontal asymptote right here, which affects the range. A log looks like this. It has a vertical asymptote and does this. And so it will never equal the vertical asymptote. So to the right 4 just takes it to the right 4, which means we've got 1, 2, 3, 4, a vertical asymptote right here, and then it does this, which means my domain is from 4 to infinity, not including 4. Number 15 is another quadratic, so anything inside the square root has to be greater than or equal to 0. So x has got to be greater than or equal to negative 10. Therefore the domain is negative 10 to infinity. For number 16, we've got a fraction again. We've got a rational function. The denominator cannot equal 0, so 7 minus x cannot equal 0, which means x cannot equal 7. So negative infinity is 7, 7 to infinity, not including 7. Number 17 is a polynomial again. It's a linear function, which means my domain is all real numbers. And number 18 is also a polynomial, so once again, the domain would be all real numbers. It's quadratic. All right, number 19. Well, actually, and this is kind of silly. It says using 7 through 14, I added some problems, so this is 19 through 29. Okay, so it says using the functions in problem. Oh crap! I'll say wait a minute. Using the problems 11 through 18, find the following and the resulting domain. Okay, so using the functions up here, we're going to do these function combinations and find the domain. Number 19 is k plus f of x, which means k of x, which is 2 square roots of x plus 10 plus 3 plus f of x, which is the square root of 5 minus x. Okay, there's nothing I can do to that. I can't combine these square roots. There's no other constants to add to 3, so that is my function. And then it says find the and the resulting domains. So for the first one, this function, it only existed from negative 10 on. But when you add this other square root, it only existed up until positive 5. So the question is, where does the addition exist? And that's only where they both exist. So the domain for this would be from negative 10 to positive 5. And that's it. All right, number 20, h minus n. So h is the cubic function, so I'm going to say x cubed minus 4x plus 1 minus n of x, and n of x is that linear, so I'm going to say minus the quantity 3x minus 4, which actually means minus 3x plus 4, right? So I've got x cubed, negative 4x minus 3x is negative 7x, and 1 plus 4 is 5. And so that's my function. And my domain, well, they're both polynomial, and they both exist for all real numbers, so the domain would be negative infinity to positive infinity, or all real numbers. So far, that has been the answer to that one. And this is the answer. Oh, well, I didn't mean to highlight that. Oh well, I did. Okay, number 21. 21 is n divided by g, so n is the function 3x minus 4. And g is the function, that's an interesting one, x minus 3 over 2x plus 5. Yeah? So when we deal with this in just a second, we're going to end up flipping and multiplying, and this will no longer be in the denominator. But do not forget that it is initially in the denominator. This function does not exist at negative 5 halves, and it never will, so negative 5 halves will always be an issue. But anyway, dividing by this fraction is the same thing as multiplying by its reciprocal. So if we multiply by 2x plus 5 over x minus 3, then my answer is 3x minus 4 times 2x plus 5 divided by x minus 3, or 6x squared plus 15x minus 8x, so plus 15 minus 8, 7, x, and then minus 20 over x minus 3. There's your function, but then as far as your domain goes, well, so first off, your original function, x could not equal negative 5 halves, and that's still true. It'll always be true. But now, in your final function, x minus 3 ends up in the denominator, which means x can also not equal 3, which means my domain is negative infinity to negative 5 halves, negative 5 halves to 3, and 3 to infinity. So everything but negative 5 halves. And so, domain, final function. On 22, it's g divided by f. So now we're starting with that original function, g. Okay, g is that rational function, x minus 3 over 2x plus 5. And we're going to divide it by f of x. So divided by f of x, which is the square root of 5 minus x. All right. When I think about dividing by this, it's dividing by that over the 1. So we're going to multiply by the reciprocal. So I'm going to multiply by 1 over the square root of 5 minus x. Okay? As far as my final answer goes, it is just going to be x minus 3 over 2x plus 5 times 5 minus x, the square root of 5 minus x. And as far as domain goes, you've got two different issues. First off, x cannot equal negative 5 halves, and it never will. And then this function, x has got to be, well, it said x has got to be less than or equal to 5. But now that it's in the denominator, we can no longer equal 5 either. So my domain would be negative infinity. We have to have a break at negative 5 halves because it doesn't equal negative 5 halves. And then we can only go up to 5, but we can't actually reach it because of the square root in the denominator. And so that would be my domain. So final function, final domain. Okay, 23 is a composition with that open circle. So we've got p of n of x. So the function p of x is 2 times the quantity something plus 3 plus 2. And that function that we're substituting in is n of x, and that is 3x minus 4. So as far as simplifying that, I'm just going to add the -4 and the 3 and call it good. So 2 times 3x minus 1 quantity squared. As far as finding domain of composition, remember we have 3 steps. Find the domain of the interior function n, that's all real numbers. Do the composition, we did, and then any resulting domain issues. Well, it's just another quadratic. So my domain would be, again, all real numbers or negative infinity, positive infinity. So, final function, and 24 is j minus f. So the function j is this logarithm. So log base 2 of x minus 4 minus f of x, which is this square root function. Okay. This logarithm only exists from 4 to infinity, and this square root only exists from negative infinity until 5. So when we look at this, we're thinking from 4 on, from negative infinity until 5. So it looks like they only exist in between. So the domain would be, just kidding, it does not exist at 4, but it does exist at 5. So the logarithm, you just kind of got to remember that you got that part of asymptote. And that's this one right here. Okay. So my function cannot simplify any, and then my domain. (25) is k divided by p. So the function k is that square root. So 2 times the square root of x plus 10 plus 3 divided by p of x, which is this quadratic, 2 times x plus 3 quantity squared. Okay, so first off, the numerator only exists from -10 on, looking at the domain up here. And the denominator exists everywhere except for now that it's in the denominator, x cannot equal -3 because -3 plus 3 would give me 0. So I have a starting point of -10, but then I also can't equal -3. So that would be my domain for that one. Okay. Final answer. I'll write over that because it's good. And then there we go. So 2 times the square root of x plus 10 plus 3 divided by 2 times x plus 3 quantity squared. And the domain, if you want to go ahead and go -3. And there we go. Okay, that's oof. Probably want to do pink and red together again. All right, so number 26 is g of m. So g is the outer function. So g of m, which is the inner function, so we'll do m of x. So m of x is this function, and g is, okay, that's what I mentioned. Is it f of n? F of n. Okay, I'm going to use as much space as I need for this one because f of n doesn't take much space at all. So g is this original function, this rational function. So something minus 3 over 2 times something plus 5. And that something is 4x over 7 minus x. 4x over 7 minus x. Okay. As far as this expression goes, let's remind ourselves about domain. The first step is always find the domain of the interior first, and we know that x cannot equal 7. So far, domain. X cannot equal 7. So that's out. The rest of what I need to do is just simplify and then see what happens to my denominator, okay? My new denominator, anyway. So I want to find a common denominator in the numerator and denominator, and it is 7 minus x. So 7 minus x on top and bottom, or remember you can just multiply top and bottom by 7 minus x of the entire fraction, and the denominator would cancel out. So I'm left with 4x minus, I'm going to distribute my negative 3. So negative 3 times 7 is negative 21, and negative 3 times negative x is positive 3x. Over the common denominator, 7 minus x. And then I'm going to do this. So I've got 2 times 4x, which is 8x, plus, and then 5 times 7 minus x, so 35 minus 5x over the common denominator, 7 minus x. So, as far as simplification goes, I've got 7x minus 21 over 7 minus x over 3x plus 35 over 7 minus x. And then if we flip and multiply by the reciprocal, so if we multiply by 7 minus x over 3x plus 35, we see that the 7 minus x is simplified out, and we're left with 7x minus 21 over 3x plus 35. So that's the most simplified version of the g of m. And then domain. So remember, we start with the interior function x cannot equal 7. Perform the composition, we did. Do we have any extra domain issues? We do. This right here, 3x plus 35 cannot equal 0, which means x cannot equal negative 35 thirds, which is not simplified. So my final domain is negative infinity, negative 35 thirds, negative 35 thirds to 7, and 7 to infinity. And that is my answer. All right, number 27. 27 is m of f. So we're going to start with the function m, and we're going to compose it with the function f of x. So f of x, let's see, m is this rational function, 4x over 7 minus x. So 4 times something over, well, I guess I should look at f of x. Oh, it's the square root. So 4 times f of x, which is the square root of 5 minus x, and then divided by 7 minus the function, so 7 minus the square root of 5 minus x. All right, that was a weird one. So, yeah. First off, domain of the interior function, x has got to be less than or equal to 5. Okay, so we know that's part of our answer. Now I'm going to go ahead and simplify. Actually, there's no simplification to be done. Yeah, you don't need to worry about multiplying by conjugates or anything. That is going to be your final function form. But as far as domain goes, we've got one other issue. We've got a new denominator. So I know 7 minus the square root of 5 minus x cannot equal 0, which means the negative square root of 5 minus x cannot equal negative 7. Just get rid of the negatives. Which means 5 minus x cannot equal, I'm going to square both sides, 49, which means negative x cannot equal 44, which means x cannot equal negative 44. And so let's check that out and make sure that we're clear on that. If x is negative 44, then 5 minus a negative 44 is 5 plus 44, which is 49. The square root of 49 is 7, and 7 minus 7 is 0. So x has to be less than or equal to 5, and it can't equal negative 4. So my final domain, negative infinity to negative 44, negative 44 to 5, and it can be 5. Okay, if this was in the denominator by itself, then it could no longer equal 5, but 5 is fine, because plugging in 5, I get 0 over 7 minus 0, which is 0 divided by 7, which is 0. Okay, interesting. I like that one. So this is my function, and this is my domain. All right, number 28 is f of n. So f of n means we're going to start with the function f, and we're going to compose it with the function n of x. And n of x, let's see, well, I got to start with what is f. F is the square root of this function, the square root of 5 minus x, so the square root of 5 minus n of x, and n of x is this linear function. So in place of x in f, I'm going to put in 3x minus 4, but we are subtracting all of that, so we got to remember to distribute. So it would be the square root of 5 minus 3x plus 4, so I'm going to distribute by negative, which becomes the square root of 9 minus 3x. Okay? When you do composition, you have to take the domain of the interior function, which is 3x minus 4, but 3x minus 4 exists everywhere. Perform the composition, and then find any new domain issues. So, in the interior of a square root, I've got to set that greater than or equal to 0 and solve, which means negative 3x has to be greater than or equal to, I'm going to subtract the 9. And then I'm going to divide by a negative 3, which flips the inequality, and that's got to be less than or equal to 3. So my final domain for this one would be negative infinity to 3. And there we go. So my f of n and the domain. 29. So 29 is m of p. So m of p of x. M of x is this rational function, so m times x over 7 minus x, and p of x equals this quadratic. So 4 times 2 times x plus 3 quantity squared divided by 7 minus 2 times x plus 3 quantity squared. Oh, and you weren't able to see. So m of x is the 4x over 7 minus x. So 4 times p of x, which is this function. So everywhere there's an x in m, we're going to replace it with this function. So 4 times this minus, or divided by 7 minus that. Okay. Domain for the interior function. I mean, there's nothing I can do here other than just multiply the numerator. I can say that's 8 times x plus 3 quantity squared. And I cannot subtract 7 and 2 because that 2 is being multiplied. Now, if you want to distribute your, if you want to expand x plus 3 quantity squared, distribute 2 and then subtract the 7, feel free, but you do not have to. But if you do want to check yourself, it would be 7 minus 2x squared plus 6x, so minus 12x, and then plus 9, so minus 18. 7 minus 18 would be negative 11, so it would be, I guess if you're going to do the numerator, you might as well do the denominator, you can do the numerator as well. If you did this, it would be 8x squared plus 48, 48x plus 72 divided by negative 2x squared minus 12x minus 11. But I don't need that from you, so if you want to do this, that's fine. Okay, domain of the interior, quadratic, exists everywhere. Composition, performed it. New domain restriction, I've got a denominator, and that denominator cannot equal 0. So 7 minus 2 times x plus 3 quantity squared cannot equal 0, which means negative 2 times x plus 3 quantity squared cannot equal negative 7, which means x plus 3 quantity squared cannot equal 7 halves. Take the square root. Ooh, that's interesting. X plus 3, x plus 3 cannot equal plus and minus the square root of 7 halves. And if I subtract the 3 over x cannot equal negative 3 plus and minus the square root of 7 halves. Oh, okay. So for domain on this one, I'm just going to say all real numbers common. X cannot equal negative 3 plus and minus the square root of 7 halves. In interval notation, it would be negative infinity to negative 3 minus the square root of 7 halves, negative 3 minus the square root of 7 halves to negative 3 plus the square root of 7 halves, and then negative 3 plus the square root of 7 halves to infinity. But as it is, that is my answer. So final function and final domain. And that is that.